Hi everyone, let's continue the factorization. In previous videos, we discussed about the different rules of factorization. As you remember, when we factorize an expression, what we do? We just take the common, then after we take a common in a group, then we use the different forms as a square minus b square, a cube plus b cube, and a cube minus b cube. Then after that, we can even use that first and last method, which we call the midterm factorization, right? Now, Now we discuss today a little bit different types of the factorization. Okay, so let's look at here. Look at this expression here. If you try to remember, if you try to apply the rules of the factorization, if I just start taking the common here, in this expression there is no common at all, right? We cannot even use a square minus b square, a cube plus b cube, or a cube minus b cube. Okay, for the moment, try to just use the midterm factorization. That means that can you use the first and last method here? If you do so, then we just here the product, that is a 1 times 1. You see the first and the last term multiplied and get the product 1 times 1. And the middle term is 1. We have to just get the sum as a 1. I think which is not possible, right? So in this situation, we have to factorize this expression a little bit different way. And before we factorize this expression, we need to understand few things here. Let's look at this one. You all know that a plus b whole square equals to a square plus 2ab plus b square, right? Now here, we can just make here a plus b whole square. Let's arrange it like, let's keep the a square and b square together, right? So it will become a square plus b square plus 2ab. If I get the value of the a square plus b square, then what do I get it? It is a plus b whole square. If I transpose plus 2ab, then it will become minus 2ab. Just remember, a square plus b square is equal to a plus b whole square minus 2ab, right? Once again, let's get the a minus b whole square. You know that a minus b whole square is also the same. That is a square minus 2ab plus b square. It is the minus, right? Now here, let's do the same thing here. I'm just trying to keep the a square and b square together and then minus 2ab. So let's get the value of a square plus b square. It will be equal to a minus b whole square plus 2ab. Minus 2ab is transposed and it will become plus 2ab, right? So let's remember these two formulas. Now we use this formula according to the situation, right? Now, look at this expression once again. See what I do here. I'm just taking the first term and the last term together. Okay, I'm just taking a4 and a b4 together and plus a square b square as it is, right? Now when you keep that one, so simply let's make it a to the power 4 as a square whole square and b to the power 4 as a b square and whole square, right? Then once I do so, it will become just like a square plus b square. Now compare a square plus b square. We know a square plus b square is a plus b whole square minus 2ab, right? Now here a means a square and b means b square. So let's compare and just try to keep the formula. Then it will read like this: a square plus b square whole square, that is a plus b whole square. Now then minus 2ab, so minus 2, a means a square and b means b square. Then the last term plus a square b square as it is, right? Now here, from here, let's simplify the like terms to a square b square and a square b square. What do we get? We get a square plus b square whole square, then minus, that is a square b square. Okay, 2 2a square b square plus a square b square. See, if we subtract it, we'll be getting just a square and b square, right? Now can we keep like this? A square b square whole square minus a square b square means that is ab whole square. Why did I keep like that? You know that if I keep like that way, it will become a square minus b square, where a means a square plus b square, b means ab, so it becomes a square minus b square. And we know a square minus b square is a plus b times a minus b, right? So let's use the formula. It will become a square plus b square plus ab, that is a plus b, right? Another a square plus b square minus ab, that is a minus b. As you know that a means a square plus b square and b means ab, right? Let's little bit arrange this one. So we can do like this: a square plus ab plus b square. We are just keeping the ab in the middle, and again a square minus ab plus b square. Okay. Now let's look at the next one example here: a to the power 4 plus 5a square b square plus 9b4. Now you understood how we factorize this type of the expression. Remember, whenever you see the power 4 in the first term, if you see the power 4, then we are using this kind of the factorization. Okay, we are using this kind of the we use this type of the factorization, that is the power 4 one. Okay, now here what we can do here. First, look at the expression here properly. If you look at the power of a, that is the power of a in the first term is a to the power 4. In the second term is a square. And the last term, there is no a. That means the power is 0. So it's completely the power of 4 is in descending order, right? So you just check this pattern here. Okay, the order of the first of the power of the a. Okay, now once we know that this is in the power 4, we use in the same way. We just try to factorize in the similar way. Okay, so what we do first, we try to keep the first term and the last term together. Okay, just make it a to the power 4 plus 9b4 and the middle term as it is at the last term, that is 5a square b square. Okay, now here we can just make it here a4, that is a square whole square, right? And 9b to the power 4, we can just make it 3b square and whole square. Okay, you try to multiply, you will be getting the 9b4 and last term as it is plus 5a square b square. Now once again, look at this one. This is exactly if you compare with a square plus b square, then we know that that is a plus b whole square minus 2ab. But here, what is a? A is a square. And what is b? B is 3b square. Now try to apply this formula, then what do we get? We get a square plus 3b square whole square. That is a plus b whole square. Minus, now we need 2ab. So 2a means a square and b means 3b square, right? And the plus 5a square b square as it is. Now, let's multiply here. A square plus 3b square whole square, then 2 times 3 is 6 and a square b square plus 5a square b square. Now look at the like terms here. Minus 6a square b square and 5a square b square. We can subtract it. Then what do we get? We get a square plus 3b square whole square, then minus from 6 minus 5 gives you the minus a square b square, right? 6x square b square plus 5a square b square, that is minus a square b square. Got it? Now here, can we do like this? A square plus 3b square whole square minus a square b square means ab whole square. Once again, this is like a plus b, a minus b, so we can just keep it here a. A means a plus b, that is a square plus 3b square. A plus b is ab, right? A square plus 3b square. A minus ab as a b. So it is a plus b and a minus b. Okay. Here we just arrange it again. It is a square plus ab plus 3b square and a square minus ab plus 3b square. Okay, let's get another example. Look at here. Look at this expression now. Now, as I told you that whenever you see the power 4, then we are factorizing in that way. But here, there's no power 4. But remember, whenever you start factorizing any expression, what is the first step always? That is taking common. Now here, you can see that y is a common, right? If you take the y, then what will remain? 449 y to the power 4 plus 7y square plus 9. Okay, now here you can see in the first term, that is power 4. And once you see the power 4, you have to follow the same rule once again. So what we do, look at the power of y here. In the first term, it is power 4. In the second term, it is a square. And the last term, it is a 0. It is in the descending order. Power of y is in descending order. In that situation, you know the rule. What we do first, we just try to keep the first and last term together. Always do the same, okay? Here, 49y to the power 4 plus 9. I'm just keeping together. And plus 7y square in the last term, right? We just keep it at the last. Now, here, what do we do here? See, 49y to the power 4. Let's make it 7y square whole square. That gives you 49y to the power 4. 9 means this is 3 whole square, right? And minus 7y square as it is. Okay. Now, once again, this is exactly in the form of a square plus b square. Which one? That is 7y square and the 3. 7y square is a, 3 is a b. So it becomes a square plus b square, right? And we know a square plus b square is a plus b whole square minus 2ab. Okay, look at here. Now, let's apply the formula. So, what will be the 7y square whole square plus 3 square? It will be 7y square plus 3 whole square, that is a plus b whole square minus 2ab. So, 2 times a means 7y square, b means 3. Okay, and minus 7y square as it is. Okay, now let's simplify it. We get 7y square plus 3 whole square minus 2 times 7 is 14. 14 times 3 is 42. Y square and minus 7y square. Okay, let's simplify it. Then we'll get y 7y square plus 3 whole square minus 42 and 7 is minus 49y square. Okay, we can keep this like this. 7y square plus 3 whole square minus 49y square means we can keep like 7y whole square. Why did I keep like that? Okay, this is the a plus b minus b whole a square minus b square. So let's keep the formula. It is a plus b and a minus b. So y times 7y squared plus 3 as a plus 7y as a b. So it is a plus b. And 7y squared plus 3 as a minus 7y is a b. So it is a plus b and a minus b. Okay. Now let's arrange it. It will be 7y squared plus 7y plus 3 and 7y squared minus 7y plus 3. Okay. Okay, now let's look at this example here. Now, you must be wondering, here is no power 4. So what we do here? So we try to apply all the rules of factorization by taking common, first and last method, midterm factorization. If you try all of these, I think we cannot apply any of the rule here. So now once again, we have to follow the same data rule which we have followed in the power 4. Okay, exactly in that way, if I do so, then can I do like this? See, the first two terms, I make it x by y whole square plus second term as a y by x whole square. Why did I do so? Because it is exactly in the form of a square plus b square, right? And you know, it is a square plus b square. So a square plus b square is a minus b whole square plus 2ab. We can apply the same formula once again here, right? Now, if I do so, then see, we'll be getting x by y minus y by x whole square. That is a minus b whole square, right? Okay, and plus 2, that is AB, and minus 11 as it is, correct? Okay, now here you must be wondering, see, before I said a square plus b square, I'm using a plus b whole square and minus 2ab. But now what I did here, I use, just change the sign. It is a minus b whole square plus 2ab. Just a little bit different here. Okay, I'm not using a plus b whole square minus 2ab. I'm using a minus b whole square plus 2ab. Why did I do so? Just imagine, if I use here a plus b whole square minus 2ab, then remember, then minus here will be a little bit different here, okay? See, from here, if we cancel x and x, y and y, there will be only plus 2. And plus 2 minus 11 gives you what? That will give you plus 2 minus 11, right? That will become plus 2 minus 11, and that will give you 9. And once again, let me remind you, if there is a, instead of minus, if I use plus here, and a plus b whole square minus 2ab, what will happen? Then it will be minus 2 and minus 11, which gives you the 13, minus 13, okay? Minus 2 and minus 11 gives you the 13, and 13 is not a perfect square. So we just change the formula here. So I told you previously that you have to use this formula according to the situation, because we know that a square plus b square is a plus b whole square minus 2ab, as well as a minus b whole square plus 2ab. Here I'm using a minus b whole square plus 2ab. I hope you understood how did I use this formula, okay? Now after that, see, look at here. Can I do the 9 as a 3 whole square? The meaning of making 9 as a 3 whole square means it is we trying to keep this in the form of a square minus b square. What is a here? A is x by y minus y by x. And what is b? B is 3. Okay, so a square minus b square means what? This is a and 3 is b. So what is a square minus b square? That is a plus b times a minus b once again. And let's keep the formula here, x by y minus y by x plus 3, that is a plus b. X by y minus y by x minus 3, that is a minus b. Okay, now finally, let's look at this example here. We have to factorize now this term. So can you think for a moment? How can we factorize it? This is not even power 4. So let's recall all the rules of the factorization here. Now, I'm sure that when you look at this expression, you must be thinking that you are trying to keep a square minus b square together and trying to use the formula a square minus b square. If I do so, then what about the remaining terms here? I think that will not help you if I use a square minus b square. So here, we cannot take even the common here. We cannot use the first and last method also, right? So in this situation, I'll give you the one concept. Look at this one. What is this? A plus b whole square. And that is equal to a square plus 2ab plus b square. This is called the perfect square, right? Now you have to try to compare with this one and try to complete the square here. So for that mean, what we do here for that reason, okay? We just make it for here. Look at the first three terms here. Closely look at the first three terms. We just make it here a whole square, considering this is a square, then plus. Now we have to keep the middle term as a 2ab. So how can we do that? Look at this. 2. A means A from the first term A, and a B we are keeping 6 here. Why? Because there is a 12A. And if we multiply 2 times 6, then we'll be getting 12A, right? So now you know that. Once I write here 2AB in this form, this is A is A and B means 6, right? So if you have to complete this as a perfect square, then I need plus b square. And what is b? B is 6. So what I need now as a b square, I need plus 6 square, right? But here is no 6 square in the first term here, first expression in the beginning. There is no 6 square. So in order to balance the expression, we have to make it minus 6 square at the same time. If I cancel 6 square and 6 square, then I'll be getting nothing. It will be balanced, right? It will be same as the previous expression here. So that's why 6 square, then minus 6 square. I just add at the same time. Okay, then rest of the terms as it is. Minus 13 plus 14b minus b square as it is. I hope you understood up to here, right? Now look at here. When you look closely here, okay, so what do you see here? Look at this. Here, if you look at here, this part only, look at this. What is this? Okay, is this the complete square? Is it the, if you compare with the a square plus 2ab plus b square, then we can just make it as a plus b whole square. So what is a? A is a. And what is b? B is 6. So let's make it here a plus 6 whole square. Okay, and then minus 6 square means 36, and then minus 13 plus 14b and minus b square, right? Now let's add 36 and 13. So it will be a plus 6 whole square minus 49, then plus 14b and minus b square. Now there is another three terms remaining at the last. So can we just keep all three terms in the bracket like that? When I keep this in the bracket, this will, all the sign will be changed. So it will be 49 plus 14b will become minus 14b, and then minus b square will become plus b square. Since there is a minus outside, we are taking common, okay, minus as a common. So these three terms, the okay, 49 minus 14b plus b square, this term, three terms, can we use the same way again, perfect square? So that is, this time is a minus. So let's make it like this. A plus 6 whole square. Now 49. I'm just trying to make it e square. That is 7 square. Now we need minus 2ab. Let's make 14b change into the 2ab. So we can do like this. Minus 2 times a is 7. And what is b? B is b. So 2 times 7 gives you 14b, right? And the last term we can just make it plus b square. Now if you compare with a square minus 2ab plus b square, it is exactly the same, right? So we know that a square minus 2ab plus b square gives you the a minus b whole square. So we can just make it like this, a plus 6 whole square, then minus, and 7 minus b whole square. Why? Because 7 is a and b is b. So it is a minus b whole square. Now, once again, this is a square minus b square. So can I keep it like this? A square minus b square is a plus b times a minus b. So here, a plus 6 plus 7 minus b. A plus 6 is a, and plus 7 minus b is b. Okay, and what is a minus b? A plus 6 is a, and minus b is 7 minus b. But I have made it 7 plus b. Why? Because there is a minus, and minus, change the sign. So it is minus b will become plus b. Okay, let's simplify this. We'll be getting a minus b. I'm keeping them together. 6 and 7 gives you plus 13. And here a plus b, and 6 minus 7 gives you minus 1.